So in this tutorial, I'm going to talk about half-life. Now, half-life is the time required for half of the radioisotopes to decay. And at the half-life, I should have half of the original amount. Now, let's say I have 100 grams of a radioisotope, and I go through one half-life. That means I lose half of the original amount. So 100 divided by 2 is 50 grams. So I should have 50 grams left. And if I say it took 10 seconds for it to go from 100 to 50 grams, I'm letting you know that the half-life time is 10 seconds. So with each half-life, you lose half of the original amount. Now, let's say we started off with 16 of our radioisotope, and it goes through one half-life. We lose half, which means that we end up with 8. Now, if we go through another half-life, we lose half of the 8 instead of the 16. So we end up with 4. And again, we did go through another half-life, and you end with 2. Now, another thing that you can encounter is trying to figure out how old an element is or a radioisotope is based on the amount that's remaining. So let's say this specific radioisotope has a half-life time that is 10 seconds. So each of these half-life is 10 seconds. So from 16 to 8, it took 10 seconds. From 8 to 4, it took 10 seconds. And from 4 to 2, it took another 10 seconds. If I were to ask you, how long did it take to go from 16 radioisotopes to 2 radioisotopes, you should be able to calculate a total of 30 seconds because it went through 3 half-lives. And each half-life is 10 seconds long. So let's go ahead and do a few examples dealing with half-life calculations. Let's go ahead and start with this problem where you are given 48 grams of a sample of carbon-14. It asks you how much carbon-14 will be left after 2 half-lives. So the first thing we're given is the original mass, and the original mass is 48 grams. And our goal is to find out how much is left. So that means what is our final mass? Now, since we are given how many half-lives it goes through, we can figure out what the final mass is going to be. Now, since we went through 2 half-lives, so 2 half-lives, that means I'm going to take the original mass, 48 grams, and divide it by 2 times because it went through 2 half-lives. And so you should end up with 12 grams. All right, in this example, instead of us being given the original mass and solving for the final mass, we have a few more components that have been added to this. We are given now the time elapsed, so the total amount of time or how old it is, and the half-life of the radioisotope. So this example states that we have a 55 gram of thorium-234 that is 144 days old. Thorium-234 has a half-life of 24 days. What is our original mass of thorium? So first and foremost, let's go ahead and write all the known variables and unknown and what we're looking for. Since we're looking for the original mass, I'm going to go ahead and write X since we don't know it. That's our unknown. And our final mass is 55.0 grams. Now, the other 2 components or variables that are presented in this problem is how old the thorium-234 is. It states there, so that's our total time elapsed. So T total is going to represent how old this thorium-234 is, and that's 144 days old. And the half-life, and I'm going to represent that by T 1/2, is 24 days. Now, we aren't given the amount of half-lives the element goes through. We actually have to solve it in this problem. And in order to do so, we are going to take the information about how old it is and how many what the actual half-life is. And you're going to determine the number of half-lives by taking the total amount of time over divided by the half-life, so 144 divided by 24, which is 6 half-lives. This tells us how many times we divided in half in order to get 55 grams remaining. So in order for us to answer this question and determine the original mass, instead of dividing 55.0 grams by 2, we're actually going to multiply it by 2. And guess how many times we're going to multiply it by 2? By 6 times, because that's how many half-lives it had went through. So 55.0 times 2 times 2 times 2 times 2 times 2 times 2, and that equals 3,520 grams. That was our original mass of thorium, and it underwent 6 half-lives to give us 55 grams left.
Okay, so in this example, we still need to know the same four pieces of information. So let's go ahead and write them out. The original mass, the final mass, the total amount of time that's elapsed, or how old it is, and the half-life. So let's go ahead and read this problem. It says there that you have 65.2 grams of an unknown radioisotope that decayed to 8.15 grams. Now, if the total time was 100 hours, what is the half-life of the isotope? So the first thing that we can do is go ahead and write what we know. It says there we started with 65.2 grams of an unknown radioisotope. So that's our original mass. I'm going to go ahead and write 65.2 grams in our original mass. And it says there it decayed to a final mass of 8.15 grams. And it says also that we have a total time of 100 hours. So I'm going to put 100 hours. But we still need to know the half-life. So I'm going to put an X there since that's what we're looking for. In order for us to determine how many half-lives we went through, so the number of half-lives, we have to choose one of these pairs. But since the only pair that's been given to us is original and final mass, this is how we're going to be able to determine the number of half-lives it went through. And in order to do that, we need to go ahead and take the original mass, which is 65.2 grams, and we just need to count how many times we divided this by 2. So the first time it's divided by 2, and we end up with 32.6 grams. That's not 8.15, so we still need to keep going. So now I'll divide this by 2, and you should end up with 16.3 grams. Again, still need to keep going until I get 8.15. So I divide it by 2 again. And this time, this gives me 8.15 grams. Now let's go ahead and count how many times we divided by 2. Here's 1, here's 2, and here's 3. So that tells me that we went through 3 half-lives. So I'm going to put that the number is 3. Since we know that we went through 3 half-lives, now we can find out what the half-life is by looking at this now. One thing you need to know is that in order to find a number using t total and t half, you still have to have, this is the equation in order to figure it out. But since we're looking for t half, this guy right here, we need to rearrange this equation. And so in order to do that, you end up with having t half is equal to the total time amounts elapsed divided by the number of half-lives. So that means, so you would divide 100 hours by the number of half-life, which is 3, and you should end up with 33.3 hours as your half-life time. So in this example, we again need to write down all the information that we need. So that includes original mass, final mass, total time elapsed, and the half-life time. So if we read this question, it says there that a sample of bone excavated from an ancient burial site was dated using carbon-14 dating. It was found that the bone marrow contained only 1/4 of the carbon found in the bone marrow. If the half-life of carbon is 5,730 years, how old are the bones? So let's go ahead and fill out what we know. We know that the half-life is 5,730 years. And we are looking for how old it is, or the time elapsed. And it tells us there, it was found that we only have 1/4 of the carbon-14 left. So that tells me my final mass is 1/4. We're going to assume that 1/4 means that there's 25% left. And if that's the case, our original mass could be just 100%. And in order for us to do this problem, we're going to do what we did in the first example, the example number 3. And so we actually have to go and take whichever pair, and the pair that's given to us is going to be the original mass and the final mass. And in order for us to determine the number of half-lives, we need to divide 100 by 2 and count how many times we divide 100 by 2 until we get to 25. So if we go 100 divided by 2, which equals 50, and divide that by 2 again, which is 25. And so we went through 1, 2 half-lives. So I'm going to go ahead and write that the number of half-lives it went through was 2. Now that we know that it went through 2 half-lives, we're going to go ahead and do the same thing, that the number of half-lives is equal to t total over t 1/2, which is the half-life time. And if we arrange this, since we want to look for t total, we can rearrange this formula in such that we have the number of half-lives times the half-life, which is 2 half-lives times the number of years, 5,730 years. And you should end up with 11460 years. But sig figs, if we were to do this properly with sig figs, it should be 11500 years. And this concludes the tutorial of half-lives, and I hope this was very helpful, and thank you for watching this video.